Hey, it's Andrew back again with the Offseason Stronghold robot project. This is a video series I'm making to hopefully help my students and anyone who follows the video project to learn design and learn CAD in general. I've taken a week or so break from this because I've been pretty busy, so I need to catch up on what we did last. I think just judging by the fact that I haven't closed my SolidWorks window since then. I think we just made the gearbox plate. It's a Flipsim gearbox. Okay, yeah, now I remember. And next step is making the assembly. So I'm going to do there, then go make a new assembly. Oh, if I remember correctly, I don't think I added the counter bores until after the video because I forgot about them completely. So what you see here is this little indents here. Those are 0.755 diameter circles that were just cut out by 1/8 of an inch in the 1/4 inch plate. And what that accomplishes is part of our standoffs that will be holding two plates together are 3/4 inch outer diameter. So it fits in there pretty snugly and it helps align the gearboxes and make sure everything fits nicely. It's a good practice we like to do. I forgot to put it in the last video. I just remember very distinctly that I ended the video and I realized I didn't do it. I didn't have time to make a whole other video, so I just wanted to fix that real quick. So it's one of the few things I'll do where it's actually not in the video itself. My goal is to get all of this, the entire process, within the video. Alright, so I get my plates aligned. I'm going to put my bearings in. Looking for is that it? No. They are 3/8 ID, a 7/8 inch OD. Cool. And we can use a smaller bearing on the end because nothing's going to go through it. But we do need a larger bearing on this plate because the shaft is actually going to go through it. So you can have a 3/8 hex going through this bearing right here, and that's we're going to turn it down to 3/8 round so it can go in there. Alright, now where's 3/8 hex? Oh, I wish there were 3/8 thunder hex. I don't know, SolidWorks does a weird thing where it likes to, I don't know, I guess it could be useful, or it auto assumes the mates, but not what I'm looking for. It's cool though, I can work with it. Also for aesthetics purposes, I guess because I don't use that bearing that much, I haven't changed the color yet. I just like all my bearings looking the same. Continuity purposes. So you noticed I put the flanges on the inside of the gearbox plates, and the reason I'm going to do that is butting up against this flange here, I'm going to have 3/8 hex going to 3/8 round, so the bearing can't go past the 3/8 hex, so that's going to geometrically retain the bearing over here. On this side, I'm going to have 3/8 hex going through 3/8 hex, and that's not going to retain anything. It's not going to retain the shaft, or it's not going to retain the bearing. So what I'm going to do is I'm going to do a snap ring or shaft collar, something super simple. I'm leaning towards snap ring because I think it can work. Just at the right distance, and doing so will prevent the plates from going any farther in and the bearings from going any farther in, and the standoffs will prevent them from going any farther out. So that'll be a nice way to retain things. Alright, so bearings down there look pretty good, or up there. On the bottom, I'm going to be running just a standard West Coast Products shifting shaft. So I'll have a 1/2 inch round on the bottom. And that second spot here actually won't have a bearing at all because that's where the bearing block is going to mount to. And I'll be getting to that in a bit. But right now, let me get my gear set up. Or actually, I'll start with the shaft. Alright, cool. I'll start with basic fender hex, and I'll cut off later on. So there's the snap ring groove right there, and that's going to be just about coincidence there with that plate. I'll make those concentric. Now I need a 1/2 inch round bearing with no flange. Alright. Cool radial. That'll work nicely there. And there's a really thin washer that's supposed to go in here. Which I should put that there, it'll show it. So there's a little bit of space in there, it's a few thousandths. I'm not going to model it because I don't like doing that. But you can. Just know that it's there for a reason, and you do need it in your actual design. Next, I have a radial thunder hex bearing. Most of the time, on traditional gearboxes, you'll use flanged half-inch hex because this is not normally thunder hex, the output shaft, but we would machine it to be thunder hex in this case because that's how I'd like it. That's going to let us use a thunder hex radial there and avoid a hex bearing. Try to use those as little as possible. And now for gears, do we have... Okay, I do not have those saved. So I'm going to use, from the last video, I determined I'm going to use the 54 and 64 tooth dog gears that 1323 used last season. Pretty sure those aren't going to be on the market. Just going to put that out here right now. So it's not like, oh, it will be a future COTS item. But I know my team's capabilities, and I know what we can machine with, and I know that making a new dog gear out of any gear that we want is pretty easy for us. So I'm going to go pull those out. Where is drivetrain? No, is it 01? I think it's 01. Nope, that's the entire drivetrain. Oh well. I'll just pull it from here. Little load. There it goes. So that's my 64 tooth. I'll just save that over to my project. And because it is a custom part, I could use the actual name. Yeah, actually, so there is a naming convention we have for modified COTS parts, and I'm going to stick with that just for continuity purposes. What I was going to do is I was going to just make it my own custom part number, and then I would know in the back of my head what it is. But if someone else wanted to look at the CAD and didn't understand what was going on, it'd probably be easier to keep this naming convention, which is why we do use it on the team. So cool, that's going to be our 64 saved there. And then do the 54 saved here. Let's see, off-season drivetrain, 02, everything good there, save, nice. Okay. So I think we're good here. Should be. Actually, 1 second. So this is really similar. I just want to see what's the spacing we used here. 2938. That's a weird number. We had a reason for spacing it like that. I think it's more because of our PTO on the top. So I'm gonna say I don't need to use that spacing. So if I don't really know what spacing I'm going to have, but I don't need to know until I have everything figured out. So I'm going to open up my two dog gears. Oh, don't need to open them. I want to insert them. So put the 54 on the inside. And I believe the reason we put the large gear on the outside is because that's going to make your, depending on how you plumb your pneumatics, it'll make your default gear low gear, I think that's it. Which, no, it makes your default gear high gear, so that when you're pushing your robot on the ground, you're not pushing against a larger reduction. That sounds right. Plus, I think it just packages it a little better for a lot of the stuff we do here. But that's fine. So those are our two dog gears. Or, yeah, dog pattern gears. Normally we'd have the actual shifting dog in the middle. I don't model it. I just know how big it is and if anything would get in the way. There would be nothing in this model that'll get in the way. If you want to model it, that's up to you. I mean, there's no harm in doing so. But I don't see a need to do it. So now we go to our 3/8 gears, pull out the hex, 375, 14 tooth, and the 24. So I believe that's what we used. They seem off color, or maybe these are the right color and those aren't. Maybe they're all the same color, and I'm colorblind. Cannot tell yet. Okay. So just because mating round with round is a lot easier, I'll make the inner part of the bearing with those spaces right there. And then I'll just drag these to approximately the right places. And I know that there's going to be 3/8 snap ring holding this together. So just for purposes of spacing wise. So yeah, 3/8 snap ring. Let me check McMaster. I think it's an 020 thickness. Gonna double check though. Let's see. I don't think you can see this. I think I don't have it set up where you can only see my SolidWorks window. So if you're not watching with sound, which I don't know why you would do, but if you're not watching with sound, you see nothing going on. That's probably why, because you're not seeing the right window. But then again, if you're not watching with sound, you can't hear this explanation either. So yeah, it's not too helpful. Okay, so I was wrong. It's 030 for 3/8 snap rings. So I'm going to space this 30 thousandths off from the edge, which will work out pretty nicely for me. And now I'm going to see how far is this approximately, because if I can, I'd like to just use a spacer that already exists there. So it's at 0.574. I could probably just use a 1/2 inch spacer, because those are already readily available. Not as much contact as I'd like, I'll be honest. So what I'll do instead is I'll see how far it is from here. No, actually, I don't want to see how far it is from here. That's dumb. I want to make this off of the gear that already exists, because right now I don't know what my distances are. I don't know where this is relative to that plate. So if I don't know that, I need to make this relative to this. So I'll say 0.6. Yeah, seems good to me. Alright, so I have my 3/8 gears. Now just to make sure I did my math right in my modeling, I'm going to put in a motor. Get a sim. And if I did this right, which I'm hoping I did, there should be enough room for my 2 gears on the inside. Alright, that's nice. Cool, exactly as I modeled it. So we do have a nice bit of space right in here, so our gears will not contact our motors. Let's see, now on the outside, 20 dp. I'm going to go to 1/2 inch hex, and this is going to be a 54 tooth gear. Ooh, I have a lightened model? That's nice. Forget when I do that to myself. Alright, make it concentric there. And I'll just make it coincident there. That's usually pretty fine. Okay, but, that would interfere there. So, cannot do that. Plus, that would move the bearing, or not the bearing, but the bolt that holds in that bearing. Or now there is no bearing holding in that bolt. No, is there? There should be. Yes, there's bearings. Okay, I'm confusing myself. So, I'm going to put this out some trivial amount, like, I'll put it out 1/8 of an inch. I'll have a spacer there, of course. but that is enough to clear there. It's more than enough, and I'm hoping that I can put a bolt head there. So to show you what I mean by the bolt heads, I think I showed an example on the WCP DS previously, but I know the thickness of this flange is about 1/16 of an inch. So if I go to my number 10 button head cap screw bolts, I go to my 5/16 length. Okay, oh, it's too long, definitely too long, too long. There it is. Cool. I don't know why it shows the sketch. I should be able to put that on top. Oh, whoops. I put the button head there. Cool. So you're seeing the bolt is holding in the flange. It is not contacting the gear, and it's not protruding out the other side. Awesome. So I'm going to get another one of those and do the same thing on the bottom. Normally I've done 3. I think we can get away with 2 though. I think it's fine. Alright, anywhere else where I need to do that trick? I don't think so. No. Cool. So that works. So that's held in. Our gear's pretty positioned nicely there. Now we need to figure out our sprockets. So sprocket wise, I'm going to use number 25 sprockets, and then we hub sprockets, probably 18Ts. Because that's really all we need here. You can go larger and it works. That's not too necessary. If you go smaller though, you run the risk of stuff popping off or not nice tension. So I like 18s. That's what we use on 1323. So I'll just keep doing that. Now as for where they are, they need to be a little bit off from this distance right here. But I need to fit the chain in as close as possible. So what I'm going to do, let me see, is I'm going to model my number 25 chain. I'm going to do this by going to the right plane. I'm going to start a sketch. Nope, just kidding, not the right plane. Should have been the top plane. Or front plane, that's it. There I go, cool. I'm going to draw a sketch right in the middle there. The height doesn't matter, which is why I can put it right in the middle of that tooth right there. What I care about is the width. So now I'm going to go online and check the thickness of the chain. I do that by going to Vex's website, because Vex Pro has their own. They sell chain there, and I think that's where we get most of our chain. And they have nice drawings. So if we go to their sprockets and chain section, it'll say roller chain. And I know you can't see this, that's why I'm saying it out loud. Scroll down to the technical specifications and say drawings. And number 25 roller chain. Alright, and there is a thickness there set as 9 millimeters. Let's see. I think that's the correct chain that I'm using. Yeah. So I'll model this as 9 millimeters. I'll just denote that. My default is in inches, so if I just say 9, it's going to be 9 inches. I just put mm and I'll say millimeters. And the height I don't actually care about. So now, my goal is to make sure that, let's say, where's this face? 0.12. So I need to have at least an 1/8 inch of space between the front of this sprocket plate right here and this side plate. So that's just at least that distance, preferably more. So I'm thinking 3/16. Thinking if I have a 3/16 inch distance, that will be plenty. 1.875. Okay, cool. So I've done my modeling, I've seen my sketch, I know exactly how much room I have for my chain, and I know as a fact of science that this will work. Now, as for how far this can go, this could, in theory, just butt up right against the sprocket. However, I do have a wheel, a motor sticking out, and it's sticking out quite a bit. Actually, it's sticking out, how far is this? 1.5 inches. So I know that this is going to be hanging over 1-inch tube. And then there's going to be a wheel at the end. I don't want my motor to intersect with my wheel, and I want room for my wires. So how do I know how far this can go out? And the way I do that is I start adding in my bearing block and my wheel. So I have a folder that says WCD, it's all my West Coast Drive stuff. I'll get my bearing block. I will attach that via the 2 mounting points here on the other side. And what a lot of people do, and what I initially did, is just mating this face to that face, but this is actually a little bit shorter than 1 inch, and that's designed so you can clamp it on. So just for mating purposes, I'll say there's a distance mate of 1 inch right there. Bearing, I'll go put a Thunder Hex bearing in there. And it has a flanged Thunder Hex bearing. Alright, and there's a flange part in there that I have the pretty nice colors, which makes it sometimes hard to see if you use black. Actually, I usually like to use this color, black, and I'm not sure why the bearing block isn't that. So that makes things at least easier to see. So you can already see where the edge of my tube is, and then the 1/8 inch from the bearing block adds in a little bit of space. And if I go to my wheels, I think if I remember correctly, I added my new wheel into my library just to make sure. Yeah, I did. Cool. So I'm just going to make that concentric there, and I'm going to mate this to the end here. Let me check my actual drivetrain model, just to make sure that I didn't add a spacer. If I add a spacer, I'd like to do that as well. Oops. Check 01. No, I think, yeah, I just butted it right up against there, which is fine. It's designed with that little nub for that purpose. I just like consistency. So I'll butt that right up against there, and you can see that sim is too close. So let me see, what's this distance right here? I always like really clean numbers. It really doesn't matter. 3.365. Okay. So I'm going to make this 3 3/8, which is the same amount of significant figures as any 3 decimal place number, but 3/8 is a nice fraction, so I'm going to do that instead. So that's going to be my spacing for the most part. Now let me get the rest of the gears in place. Actually, let me do a quick, no, I'll do a quick mirror later. I'm going to go back, and I specifically designed this to use the 11T pinions. It gives me the ratio I'd like, and I'm just going to make that concentric there. That's For distance, that looked good. Really doesn't matter. It could even be inside for all I care, because it's small enough. But for all intents and purposes, the distance does not matter, as long as it's not way out here. If there's contact being made, there's contact being made, and that's all I care about. So I wouldn't even mate it. Now, as for the other gear, I actually completely forget what gear I used as a idler, So I'm going to go double check that in my sketch. 54, and okay, so I used a 20 tooth. Okay, discard changes. I haven't made any changes. So I'm going to get a 1/2 inch 20 tooth gear. And what I'm going to do now is, the way I would make my idler work is, if I go to my bearings folder, I have a bearing that's a 1/4 inch inner diameter and a 1/2 inch outer diameter, and it's flanged. Here it is. Cool. This is what we used in season on 1323's robot. So these are nice because I could just cup them right between, right over there. Because it's a 1/2 inch round outer diameter, it's a 1/2 inch hex bore in the gear, it actually slides right in, and it supports it surprisingly well. So I put one on either side. And the mistake we made this year is we just bolted it through right here, and we had nothing on the other side. And I think that sort of decreased performance a little. So our solution to that would be to add another plate on the outside or something else to support it. I think I'm going to make some simple sheet part or something that'll go off the mounting holes here and here, and the hole right here, and that goes to either side. So distance wise, I think I still have this an 1/8 inch off. What do I have? 0.1, yeah, 0.185. And that's going to connect nicely there. Actually, a normal distance there, so actually I will change that to be a 1/16. Okay, so that's nicely in the center there. That's better. Cool. Yeah. So I'm just going to mirror that to the other side now, across my, not my right plane, across my front plane. Alright, so this is most of the detail work the gearbox done, not the detail work, the opposite detail work. This is most of the guts of the gearbox. It's a terrible way of saying it. And those bearings flipped. Did they? Yeah, they totally did. So we had a slight problem with the mirror where the bearings flipped. That's fine. I'll just fix it by making the right hand feature. And the other bearing is there. I'm blind. There. Okay, cool. So that's going to work out nicely for us right there. We're running a bit close on time, about half an hour already. This is most of the gearbox right here. Oh, got to mirror the motor, actually. I forgot about that. Nice. So this is it. For the most part, it's missing standoffs, it's missing some spacers. It's missing a shaft. Kind of helpful. But other than that, that's the main idea of it. That's the nitty-gritty. In the next video, we'll finish it up, start putting it in the drivetrain. We'll get some lightning done. Also get a shifting shaft in there. That's helpful, like a pneumatic cylinder. It'd be nice if your shifting transmission could actually shift. Alright, so that's it for this video. I will see you on the next one.